All right, everybody, hello and welcome back. Today we're going to do is we're going to work on solving logarithms. So before we kind of get into that, there's a couple things we want to make sure that we remember. So if we have log base 2 of x equals 6, let's say we were to want to get rid of this log. Well, in order to do that, we would need an exponential that has the same base. So I think the property we looked at was actually log base 2 of, let's say, 2 to the x power. What we noticed is when we had a log with the same base as an exponential, they would cancel each other out, and then whatever we had left was our solution. So one thing that we're going to want to do, let's just not do this example, is keep that in mind, that logs and exponentials are inverses of each other, so they are going to undo each other. Now, we can also look at this similarly. If we want to undo this exponential, then we are going to have to put a log with the same base on either side. The reason this is important is because in our log and our exponential cancel, and we get x by itself. So we're going to use those properties to help us evaluate logs today. Now, we're going to be putting together some of what we've talked about over the last couple days. We are going to be condensing, and we're going to be using those properties above to help us solve. So this is our first example. Now, as soon as we start throwing in the equal sign here, some of us feel a little bit more challenged. So if it is helpful, we can kind of just pretend that it's not there. If we focus just on this part here, we have two logs with the same base, subtraction between them. Our properties of logs tell us that we are going to condense using our quotient property. So this is going to condense to log base 2 of x divided by 4. So we condense just like we have been doing over our last couple days, but now let's remember that this is actually set equal to 2. If we go back to our properties of logs and exponentials here, they are inverses and therefore they're going to undo each other as long as we have a log and an exponential with the same base. In this case, if I want to get rid of this log, I'm going to need to have an exponential on that side that has the same base. So we're going to complete the process that we've talked about before called exponentiation, where I'm creating an exponent, and each side is going to be the exponent. So I've done it to one side. Now I'm going to do the same base on the other, and then take my exponent as what was left on that side. So essentially, this part is going to here, this part is going to here. We are creating exponentials on both sides where the base is 2 in each. Now the reason we want to do this is because now our log and exponential will cancel, and we have just our argument, which is x divided by 4, is equal to 2 to the second power, which is also 4. The last thing I'm going to want to do is I'm going to want to isolate x and get it by itself. So I'm going to multiply both sides by 4. And I'll be left with x equals 4, and 4 is 16. So that is how we are going to solve logs. We're going to use our condensing properties to essentially isolate the log by itself. And then we're going to use the idea that logs and exponentials are inverses to undo each other. Then all we have to do is isolate the x value. Now, what I want to make sure that we're doing is we should always be going back in and we should be checking our work. So what I'm going to do is I'm going to take my original problem. I'll just copy it right here. And I just solved to get x is equal to 16. So all I'm going to do is plug this into my calculator to make sure that it works. Now, we could use some mental math here, and we could see that log base 2 of 16 is saying 2 to what power is 16? The answer is 4. Log base 2 to the 4th is saying 2 to what power is 4? The answer is 2. 4 minus 2 is, in fact, 2. So this checks out. What that means is we got our solution of x equals 16, which is, in fact, the correct solution. Now, again, if you wanted to, you can do that on your calculators as well. Just a quick reminder, click on Functions, scroll all the way down until you see a log with a base. We have 2 of 16 minus I didn't want to do that. One more time. And the answer is 2, as we can see. So you can always check with the calculator. All you want to do is make sure that you're holding yourself accountable and double checking, because sometimes this doesn't actually work out and we get what is called an extraneous solution. Now, an extraneous solution is a false solution. It is one we get from solving our equation that actually isn't a solution, just given how we ended up solving seemed to be one. All right, so let's just keep rolling. We've got a problem like this here. Again, we are going to condense first, almost pretending that our equal sign is not there. So we've got our power properties, so that's going to go back up top. We will get log base 3 of x squared plus log base 3 of 9. And again, now we can use our product property, and this will become log base 3 of, since we are adding two logs that have the same base, we can multiply their arguments. And now we got to remember that this should be equal to 3 the entire time. So we're kind of stuck here. We've isolated our log. We've condensed as much as we can. What I need to do is get rid of the log. Now, to get rid of the log, I'm going to need to exponentiate both sides. So I am creating an exponential that has the same base as my log so that they cancel each other out. And I get 9x squared equals 3 to the third power, which is 27. Now I'm a little bit short on room, so I'm actually going to finish this off over here. And all I have to do here is divide by 9, divide by 9. I get x squared equals 3. And then to get rid of my square, I'm going to have to take the square root of either side. We get x equals plus or minus the square root of 3. Now, that's a pretty ugly solution, but it doesn't really change anything for us. Our solutions are positive square root 3 and negative square root 3, both of which need to be checked. So if we just copy what we had before, and I am going to replace my x value with positive square root 3 first. So this is definitely something I'm going to do on a calculator. I think we should be equal to 3 here. So I'm just going to type this right into my calculator just to make sure. We have 2 times log base 2 of, I think it was square root. It should be log base 3. I don't think I can fix it. Awesome. And then we're going to, what was it? Let's see. Add log base 3 of 9, and we do in fact get 3. So that tells us that positive square root 3 works, but now we should double check with the negative square root 3. Now when I do this, I get an undefined value, and that is because we cannot take the log of a negative number. So what that tells us is that this did not equal 3, and therefore this isn't really our solution. Our only solution is x equals positive square root 3, because we would say that x equals negative square root 3 is extraneous. Okay, so that's why we check our work, all right? We solve like we normally would by condensing, and then we double check both solutions. Some might work, some might not. Now, let's take a quick look at a couple more examples. So here we have the natural log of x minus 4 equals the natural log of 2x minus 6. So there's no real condensing we can do on either side because we have one log and one log. But if you notice, those logs are the same. If we kind of ignore one side for now, if we wanted to get rid of this log so we can isolate our x value, we would need to create an exponential that had the same base as this log. Well, the natural log has a base of e, so I'm going to exponentiate both sides so that these will cancel. Well, if I do that to one side, I have to do it to the other. And since both sides are the same types of logs with the same base, they'll cancel each other out, and I get x minus 4 is equal to 2x minus 6. So I move over my x, add my 6, and we will get x equals positive 2. So basically the solution here is when you've got one log equal to another log, and each log is by itself and their bases are the same, you can essentially just cancel them out and solve their arguments by setting them equal to each other. Just real quick, just to double check, we've got the natural log of 2 minus 4 equals the natural log of 2x minus 6, and x here is 2. As you can see, we get the natural log of negative 2 equals the natural log of negative 2. Now that looks a little bit strange. They look like they are simplified with each other, equal to each other, excuse me. However, when we plug this into our calculator, we can't take the natural log of a negative number. So therefore, both sides do not work, and this is an extraneous solution. So the only one that we got was extraneous, so therefore we would say no solution to this log. All right. Lastly, we've got a problem like this here. So again, we've got log base 2 of x plus log base 2 of x plus 4 equals 2. So again, we're kind of pretending the equal sign is not there. We are going to condense using the product property. And now we bring back that equals 2. Sometimes I think it helps just to pretend it's not there. And what we can do is we are going to need to exponentiate to get rid of this log. So if I put each side in the exponent with a base of 2, we are exponentiating, and therefore my log will cancel. And I'm going to be left with x times x plus 4 is equal to 2 to the second power, which is 4. We end up with x squared plus 4x, right, distributing, equals 4. And if I just subtract my 4 over, we get x squared plus 4x minus 4 equals 0. So this is a quadratic. We are going to have to solve quadratics to some extent here. Now, there's a couple different ways we could solve quadratics. We could solve by taking the square root, which we have actually, there it is, already done. You can factor, and you can use quadratic formula. But we could also graph. So, or at least we could try all of those things. Graphing is typically going to be the easiest because all we have to do is type that into our calculator. We get x squared plus 4x minus 4. And those are our solutions right there. So they're not very nice numbers. However, we can kind of see what that looks like here. So again, I made this problem up, so it didn't work out perfectly here. However, if we wanted to, we could take a look at the graph, and we get our two x-intercepts, which are in fact solutions of about negative 4.82. And then we get about 0.8 3. Those are going to be our solutions. Those are really irrational numbers here. And we can kind of double check by plugging into our original. Now, it's not going to work out perfectly because we are rounding. And if we notice, what happens here is that we're trying to take the log of a negative, and this will also be negative, which we cannot do. So therefore, this does not work, and this is not actually a solution. Now, we can try our other value that we got, 0.83. And let's double check our work. Log base 2 of 0.83 plus log base 2 of 0.83 plus 4. As you can see, that gives us a little bit larger than 2, which should make sense because we rounded this up to 0.83. So that tells us that this does in fact work out. And our only solution is when x is approximately 0.83. So this one worked out a little bit strangely. The point that I was trying to make is sometimes when we end up solving, we have to solve quadratic functions. Now, we haven't really done that too much so far. So what I would recommend is just graphing and looking at the x-intercepts. Those are going to be our solutions. So a couple big takeaways here. When we are solving logs, we are going to condense first, then use the fact that logs and exponentials are inverses to exponentiate both sides and cancel. And then we can't forget to check our work. All right, we always need to check our work because we might get extraneous solutions that are actual false solutions when we are in the solving process. Now, there's a couple unique situations here, again, where we might have to solve quadratics or where we have one log equal to another log and the bases are the same. If that's the case, they just cancel. If this is the case, remember, we just graph, and we should be able to kind of go from there. All right. As always, thank you for listening. If you have any questions or concerns, please feel free to reach out.